Hey everyone, thanks for joining me today for a fun-filled, fast-action, and fact-packed trip through the cosmos to learn more about the exoplanets we know about, and everything we don't know about the exoplanets we know about. We'll travel to the universe's most dangerous planets, our most terrifying planet, and a few planets we might be able to call home. But be warned, this is What If. You're likely to be killed on whatever exoplanet we drop you on. That's just the way it is. The guys get killed. Okay, this first one is full of mayhem and death and dismemberment. Not of you, of my little buddy, Chase. I mean, his whole thing is that he dies in space, so really this isn't that big of a surprise. It's called What Would Dying on Every Planet in the Universe Be Like? Now, of course, a video covering every exoplanet in the universe would take too long, so I made sure to pick only the meanest, nastiest, most ornery planets I could find. Chase dies. A lot. But today, he's dying the most. Chase will be dying on every exoplanet, and though we couldn't include every single one because the universe is pretty big, we made sure to include the most gruesome. Starting with Kepler 22b.
I'm not going.
Kepler 22b is a super-Earth. It's 2.1 times the radius and 9 times the mass of our planet. It orbits in the habitable zone of its star, so it has all the necessary conditions to host life. But just like any other planet, it also has a ton of ways to kill you.
Oh, great.
No one has ever been to Kepler 22b to confirm, but this planet could have an oxygen-rich atmosphere.
Oxygen? You're gonna try and kill me with oxygen? Yeah, good luck with that. I breathe that stuff basically all of the time.
Well, too much of that could be fatal.
Oxygen? Seriously, oxygen can kill me. Watch this.
Detecting 32.8% of oxygen. Poisoning imminent.
See? It's fine. I've got...
It's not fine. It's hyperoxia.
This feels like a big round fishbowl.
Kepler 22b is big. It's more than twice the size of Earth. It's likely that the pressure on this exoplanet is also a lot higher. And when you mix an oxygen-rich atmosphere and a high-pressure environment, you get a collapse of your entire cardiovascular system within minutes. At first, your face and hands would start to twitch. You'd feel nauseous. You'd still feel this oxygen euphoria, but at this point, you'd also be experiencing tunnel vision. Soon, you start coughing your lungs out. After 10 minutes, you wouldn't be able to stand. Your body would start shaking and your coordination would become, well, uncoordinated. You won't be fighting this long. Inside your body, your lungs are about to collapse. That's just one of the atmospheric gases that could kill you. If Kepler 22b has too much carbon dioxide in its atmosphere, you'd be gone even sooner.
Rocks, okay. Yeah, no, I will not be opening my helmet again, okay? Last time was an accident, and I'm not stupid enough to press this button again.
Warning, critical carbon dioxide levels detected.
Why isn't this button closing?
Unlike breathing in a lot of oxygen, inhaling a lot of carbon dioxide would not make you feel happy. It would give you instant hypercarnia. That's when you have too much carbon dioxide in your bloodstream. You'd only have 10 minutes left to live. You'd start breathing faster, and your heart rate would go through the roof. The pressure would build in your brain, and that would make your vision blurry. Well, you could lose it completely. Then there's nausea, seizures, and finally, total cardiovascular collapse.
What? No. I feel fine. Like, really good. Look. I just, I can't see or feel stuff, and I feel really sick.
And these are just two known atmospheric gases. Now imagine all the alien compounds we don't know. Kepler 22b's atmosphere could have an acid gas that burns you from the inside, or an acid gas that burns you from the outside, or an acid gas that...
No. Let's stop speculating on different acid gases.
Well, speculating is kind of our whole thing, but sure, let's go with something we know. Kepler 22b's thick atmosphere could create unbelievably intense storms. Plus, this planet could have sulfur dioxide or nitrogen oxides in the atmosphere. These chemicals would mix with water and become acid rain.
Oh, God, seriously, what's wrong with you? What's up with you and acid, man? Is this like a kink of yours?
Sorry, Chase, we're just on the acid part of the video right now. Okay, so if a super-Earth planet like Kepler 22b had this thick, high-pressure atmosphere, it means it would also have extreme storms. In storms this intense, you can easily expect to see frequent strikes of gigavolt lightning. And as everyone knows, it's best not to stand near tall objects during lightning. If you can believe it, Kepler 22b is the most potentially habitable of all the exoplanets in this video. I'll give it a 5 out of 10. It only gets worse from here. TRAPPIST-1d is one of 7 Earth-sized exoplanets packed tightly together in a star system 40 light-years away from us. The distance between some of these alien worlds is even smaller than the distance between Earth and our moon. All these planets orbit a cool red dwarf star, TRAPPIST-1, and at least 3 of them are in their star's habitable zone. It's cool because TRAPPIST-1d could have liquid water on its surface, and you'd also see the other TRAPPIST planets from down there.
Yeah, he's right. Check it out. There's TRAPPIST-1c and b. Yo! Anyone over there? What's the move tonight? We getting crunk?
Yeah, because TRAPPIST planets are so crammed together, asteroid impacts on these worlds are more frequent and unpredictable. An asteroid that gets ripped apart by one planet's gravity might rain down on TRAPPIST-1d as a meteor shower. And that could be deadly. But that's not the only deadly thing about this system. All the TRAPPIST exoplanets orbit their star very quickly. TRAPPIST-1d orbits once every 4 days. Orbiting that quickly and that close to their star creates insane weather patterns. Because of its proximity, TRAPPIST-1d receives direct and violent gusts of stellar wind. That's not a real wind you can feel. It's a rush of charged particles that hit the planet so quickly and powerfully that they strip away the atmosphere. During stellar wind, TRAPPIST-1d's atmosphere heats up and expands, and it bakes the planet in the process. When the wind dies down, the atmosphere shrinks and causes sudden drops in pressure. This cycle creates strong winds and rapid temperature changes down on the planet.
That does not sound good.
Plus, TRAPPIST-1d is tidally locked with its star, and that adds to the wild pressure and temperature differences.
Okay, so I'm on the day side right now, and it's already pretty toasty over here. Rico, can we get a temperature reading around here?
Current temperature 35 degrees, 38 degrees, 48
Why
degrees,
is it going up so fast?
55 degrees, 73 degrees.
Oh, God. Oh, man. There must have been a stellar wind or something. I'm so cooked.
TRAPPIST-1d is pretty epic. I like that meteor shower, that looked beautiful. I'll give it an 8 out of 10 for the visuals. Kepler 186f is the most Earth-like exoplanet we've found within the habitable zone of its star. It's 10% larger than Earth and around 40% more massive. This planet could be a true Earth replica outside our solar system.
Wait. No warheads? No missiles? No Brussels sprouts? This is better than Earth.
Temperature reading 23 degrees Celsius.
Balmy. I like it. It makes me want to frolic. Oh, man. Now this is ripe for skipping. Rico, analyze the oxygen levels. I want to take my helmet off.
Atmospheric oxygen at 24%.
Oh, awesome. Perfect. I'm sure it's fine to take it off. Look at this place. There's life everywhere.
Plant life on an alien planet doesn't mean that the planet is habitable for you. Life here may have evolved differently.
Whatever, Peter. Sometimes you just have to take a little risk and let your innie chase G out. Seems okay. Everyone, I think this is a winner.
It's one thing to breathe in alien air, but breathe in potentially deadly alien plant spores? Yeah, that could happen. On alien worlds, anything could happen. Hey, just for the record, I'd take more risks too if I knew I could come back to life after I died. All right, let's continue.
Okay, yes, I happened to take my helmet off in the field of a bunch of toxic spores. Ugh, sue me. Space evolution is crazy. The plants here are not okay. This guy is staying on. Huh. Rico, what's this rain made of?
Current rainfall composed of 100% sulfuric acid.
Acid rain again?
Some moons and planets are known to have regular rainfall of chemicals other than water. For example, Saturn's moon Titan is so cold that it rains methane there. Kepler 186f isn't cold enough for that, but the rain of any planet will always react with the gases in the atmosphere. If this planet has enough volcanic activity and sulfur dioxide produced from natural decay, that rain could be pretty concentrated.
Are we done with this exoplanet, Peter? I want to get out of this rain.
Sure, we can be done.
I'm gonna try sprinting back to the ship.
looks like we weren't quite done. The sulfuric acid burned straight through him. Ugh, that looked like a chemistry class. Or an alien movie. Not sure. I'd give this planet 4 out of 10. Would not recommend. This is Proxima Centauri b. Its constant exposure to radiation makes it the Hulk of exoplanets. This planet orbits Proxima Centauri, a red dwarf star that's only 1/8 of our sun's mass, but capable of releasing solar flares 100 times more powerful.
Man, talk about a Napoleon complex. Proxima Centauri, it's compensating for something. For surezies.
Right. Well, in 2019, scientists recorded one of the largest solar flares we've ever seen. Proxima Centauri burst into a violent mega flare and became 14,000 times brighter for the whole of 7 seconds. These radiation spewing events aren't just a once-in-a-century type of thing. Proxima Centauri has solar flares erupting every day. 1 second on that planet and your body's poisoned. And Chase has already been there for a minute.
Well, Peter, it's a good thing then that my suit is insulated against radiation. Ha ha ha.
Yeah, not against the amount of radiation coming from Proxima Centauri.
Body radiation levels at 51 sieverts.
A sievert is a measure of radiation exposure in your body, and 51 sieverts means lethal.
Ah, well, it's funny you say that, Peter, because I do not feel good. Oh, God.
Right now, Chase's genetic code is actively being mutated, causing slow and total organ failure. Over the next few hours, Chase's bone marrow will stop producing blood cells. His GI tract will shut down, and failure in the circulatory system will cause fluid to build up in the brain. It's anyone's guess which killed him first. Proxima Centauri b is one of the most all-round lethal exoplanets. Even if you could withstand those radiation levels, it'd be difficult to manage the extreme weather patterns. This exoplanet is tidally locked with its star Proxima Centauri, meaning one side is constantly heated by the star while the other is permanently cold. On the day side, the air is heated and rises, and then cooler air from the night side rushes in, causing constant winds up to 75 kilometers per hour. That might not be powerful enough to knock you over, but any object moving at that speed would put a hefty dent in any spacesuit. Even a rock as small as, well, that one. And with Proxima b's thin atmosphere, well, yeah, well, watch out for the winds and rocks. Proxima Centauri b gets a 5 out of 10. Moving on. Next on the list, Kepler 452b. 60% larger than Earth and 1.5 billion years older, Kepler 452b is like the wiser version of Earth.
Look at that. Another Kepler planet I get to die on. Great.
Come on, Chase, we just got here.
Yeah, but, look at that. It's looking at me funny. This is how I die on this one.
Well, that just looks like a plant that has evolved to withstand Kepler 452b's higher gravity and intense sunlight exposure. If the conditions are more intense, life has to be more resilient.
Yeah, fine, I get it, but like, this thing is a bit much. I mean, what even is it?
Ooh, even I didn't see that coming. Okay, should we move on? All right, moving on. You know how Earth has tectonic plates and they move around? Well, the same thing could happen on Kepler 452b.
What am I supposed to do? Is it like hide under a desk or a door frame? I don't see any desks or door frames on Kepler 452b. It has plenty of carnivorous plants, but no desks to hide under in case of a Kepler quake. That's it. That's it. I'm done.
Suffocating again? Can you check the script? We need more variety here. This is pretty dull.
Peter, just before this one, he was like eaten by a giant alien plant. Like, what does he want?
Right. No, you're right. Okay, well, that's a 7 out of 10 for me then. It just would be nice if we had more action sequences. 55 Cancri E is an actual hellscape of a planet.
Oh, great. So awesome. I love it, actually, when you describe planets as hellscapes. Rico, whatever, let's just get this over with. Take us down.
Like most rocky exoplanets that orbit close to their stars, 55 Cancri E is tidally locked, and yes, it's about 2.2 million kilometers away from its star. It may sound like a lot in Earth terms, but in space terms, that is really, really close. The surface temperature on the day side of the planet is over 2,400 degrees Celsius. That means the ground here isn't even rock, it's molten lava, which Chase is about to find out.
Are we there yet?
No.
Are we there yet?
No.
Are we there yet?
No.
Are we there yet?
Negative.
Are we there yet? Are we there yet? Are we there yet? Are we there yet? Are we there now?
Landing complete.
Finally.
Atmosphere reading 79.32% silicon oxide, 18.83% carbon compounds.
55 Cancri E has a unique chemical composition. Carbon is a huge component of its rocky material, which means a third of the planet's mass is actually pure diamond.
Okay, why didn't you mention this earlier? Oh my god, I'm gonna be rich, baby! Say it with me, folks. Hashtag see you later, Burger Debt. Oh, I have a bad feeling about this. Oh, this gives a whole new meaning to the floor is lava. Okay. This is gonna be slow and painful. Great. Rico, play me out to some jazz.
When I said hellscape, yeah, I really meant it. Venus is the hottest planet in our solar system, and it's only 464 degrees Celsius. This is 5 times hotter than that. I'll give this planet a 7 out of 10. This dark and rocky planet is as inhospitable as it looks. LHS 3844b, wow, that's a mouthful, is tidally locked and is in close orbit with its star. Its day side is always around 765 degrees Celsius, and its night side is hundreds of degrees below freezing. With absolutely zero atmosphere, there's no way for heat to transfer to the other side of the planet. LHS 3844b is completely exposed to the dangers of space.
Yeah, well, it's a lot like me in that way. Exposed to the dangers of space. So that's it? That little thing right there? What is that, like an M dwarf? I mean, like, it's giving M dwarf, but man, there's hardly any mass on that thing. Girl, eat something! Yikes. She did not like that.
That solar flare just showered this entire planet in a lethal dose of radiation. Sorry, Chase. It's gonna happen again.
The radiation? Again? But that's how we started the video, Peter!
Yeah, you know the drill. Total collapse of every system in the body. Oh, it looks like this time you're losing your hair, too. You managed to avoid that last time. And this time, the radiation blast got Rico, too.
Tell me the radiation stuff is over.
Only time will tell.
Oh, God. This is even slower and more painful than dying in lava. And there's no jazz!
The real moral of the story here is that space is extremely radioactive. LHS 3844b is not a planet I'd put on your space travel itinerary. 1 out of 10. Now, if you didn't catch what an exoplanet is, well, it's just a planet that orbits a star outside of our solar system. They fascinate us because of their potential to show us how planets form and how they evolve. But also because they make us dream about the possibility of life beyond Earth. That's something we're going to see in our lifetime? You know, scientists theorized for centuries that exoplanets existed, but we only discovered the first one in 1995, a planet named 51 Pegasi b. Since then, we've discovered about 6,000 of them in over 4,400 planetary systems. Trying to picture all that up in the sky is a bit mind-boggling. Let's take a break and travel to the closest one, Proxima Centauri b. Just 4 light years away from Earth sits the closest exoplanet that scientists have discovered, Proxima Centauri b. And it could be the first exoplanet where we find extraterrestrial life. Who better to check it out than our interstellar teammate, Chase?
Yeah, it's true I've died on every exoplanet I visited, but this time will be different.
Your death count is well above average.
Yeah, but Proxima Centauri b has to work out. It's gonna work out. It's literally so close to Earth that I could DoorDash my tuna pizza order, like regular. Plus, the whole system is moving closer to Earth, so in 30,000 years, this whole thing is gonna be 3 light years away.
The bad news is, after another few thousand years, Proxima Centauri b will move further away from Earth, and HH Andromeda will become Earth's closest star, besides the Sun. And unfortunately, that star doesn't have any planets.
Ugh, why do you have to be such a bummer all the time?
Even though Proxima Centauri b is in the closest star system to us, it's still far away. If you left Earth today, you'd reach the Alpha Centauri star system in some 165,000 years, give or take.
Look, we're almost there. You can see all 3 stars from here.
That's right, Proxima Centauri b orbits one star called Proxima Centauri, and this star is part of the Alpha Centauri star system that has not 1, not 2, but 3 suns.
There's Alpha Centauri A and B. Those orbit quite close to each other. And there's Proxima Centauri. So that orbit's much further away, but they're all gravitationally bound together. It's kind of like how Rico and I are 2 peas in a pod. We're just really close and cool guys together. And Peter, he's just around, you know? And we'd like him to stay all the way over there.
Computers have no loyalties or emotional affiliations.
Wow, Rico, ouch. Whatever, man, just initiate landing on Proxima Centauri b. All right. Oh man, this is sweet.
Proxima Centauri b is located in the habitable zone of its host star, but just because it's in the habitable zone doesn't mean it's habitable.
Yeah, just because it's in the habitable zone doesn't mean it's habitable, and just because I die on a planet doesn't mean it's not habitable. Keep up, people.
Though he could have said it better, Chase isn't wrong. Proxima Centauri is a red dwarf star, which makes it very different from the Earth's sun. As a red dwarf, it's much smaller and cooler. It's also a lot more efficient at burning through all of its hydrogen supply. And that means that Proxima Centauri has a lot longer lifespan than the sun. This red dwarf will shine steadily for trillions of years, long after the sun runs out of hydrogen and swells into a red giant.
Oh yeah. In 5 billion years, when all these little Earthlings die off because of an apocalyptic sun explosion, I'll be up here chilling like a villain for another 4 trillion years. Yeah.
Well, Proxima Centauri b might not be the best place to chill. Its star, Proxima Centauri, only gives off about 0.1% of the sun's brightness. That means that Proxima Centauri b has to orbit much closer to its star to get enough energy to potentially support life. And being too close to a red dwarf star comes with some dangerous consequences.
Ugh, don't tell me. The solar flares? I always forget about the solar flares.
That's right, this red dwarf star gives off deadly, unpredictable blasts of extreme radiation. These eruptions carry so much energy that they could strip away the planet's atmosphere.
No! Why? No! Why does everything always have to have a downside? No! Oh, why can't life just be good for once?
Ultraviolet bursts from the red dwarf star strip electrons from the particles in the planet's atmosphere. As more and more negative electrons escape into space, they pull the positive ions with them too. This constant escape act strips away most of the atmosphere, leaving the planet with barely any gas to hold on to.
Well, if that's true, this might not be that habitable after all. Rico, let's get an atmospheric reading.
Sampling. Calculating. Thin atmosphere detected. Trace amounts of carbon dioxide, methane, and nitrogen.
All right, well, let's explore a little. See if we can find some water, maybe a place to build a shelter. I can still turn this rock into a home.
Proxima Centauri b has another dark secret. It's tidally locked with its star, which means the planet rotates at the exact same rate that it orbits around Proxima Centauri. Only one side of Proxima Centauri b is facing its star, and that side is forever exposed to light. The other side, shrouded in endless darkness.
Well, that's pretty dramatic, right? I have to choose my spot carefully. Do I want to be a lecherous creature of the night or a wholesome daytime guy? All year round seasonal depression or chronic sunburn? Partied up rave style or read a book sometimes? Tough one. Oh man, this is tough. Oh, I know. I'll live in the Terminator Zone.
The Terminator Zone is the area between the day side and the night side of a planet. Earth has one too, but it's constantly moving. On a tidally locked planet like this one, the Terminator Zone stays in place.
It should have a more moderate temperature and easy access to both sides of the planet. It may also be where I can find water, and don't even get me started on the fact that the Terminator Zone is the most habitable place on this whole planet. It just doesn't make sense. Terminator Zone. Hasta la vista, baby. Who is your daddy? What does he do? Get to the chopper. Get to the chopper! Get to the chopper!
Arrived at the Terminator Zone.
The Earth's Terminator, or Twilight Zone, stretches around 60 kilometers. Now, if Proxima Centauri b has a thin atmosphere, its Twilight Zone would be a little smaller.
Still good enough to build my shelter. All right, let's get to work. I'm making all of this radiation proof. You know, with the amount of UV this guy's blasting off, we have to insulate everything.
Of course, no one has ever been to Proxima Centauri b to confirm if it has an atmosphere and what that atmosphere is like. To find out the atmosphere of distant planets, scientists use a method called transit spectroscopy. When a planet crosses in front of its star, some of the star's light passes through the planet's atmosphere. By studying the changes in that light, astronomers can determine which gases are present in a planet's atmosphere. And we can do that from Earth. It's pretty cool. But transit spectroscopy doesn't work on all exoplanets, and it doesn't work for Proxima Centauri b because this exoplanet doesn't transit its star in a way we can study it from here. If Proxima Centauri b doesn't have an atmosphere, well, it could have a surface temperature of minus 40 degrees Celsius. If it does have an atmosphere, well, then it could be as warm as 30 degrees Celsius. This would be great news because that would mean that Proxima Centauri b could sustain liquid water on its surface. And where there's liquid water, there could be life.
Oh man, this is hard work. I'm getting really hot in here. I'm gonna take a quick trip over to the night zone, you know, cool off a little bit, have myself a little cocktail, see if there's any space ladies over there. Okay, well, I cooled off. I don't know where I am. It's super dark over here, and I can't see, anything. Rico, can you direct me back to the Terminator Zone, please?
The Terminator Zone is 5 kilometers north.
Okay, which way is north, Rico? I can't see anything. Which way is north, Rico? I don't have a map. I can't see anything. There's no rocks. There's no sun. Which way is north, Rico? You know, I'm gonna reprogram you when I get back to the spaceship. I'm gonna make you not such a loser. You know what Rico probably stands for? Really annoying. Help? Anyone? Rico? Peter? Ugh, even he's not answering? Alright guys, get in the comments. figure out which way is north, okay? I can tell you that this way isn't north, so help! Okay.
Well, it looks like we lost Chase to the darkness of Proxima Centauri B. Which is too bad. He doesn't actually come back unless he dies.
Oh God, I made it. Oh, I thought I was doomed back there, stuck to wander in some sick cosmic purgatory for all my life. I need to take some sort of daytime mental health break. Rico, get me my relaxing chair. Oh, that's beautiful.
He should have stayed in the Terminator zone. A blast like that straight to the face? The heat and radiation would cook your insides in a second. This is one of the most dangerous planets in the universe. It's a massive, desolate planet that's incredibly hot and has zero atmosphere. This is TOI 849b, and it's the largest rocky planet that we know of. If you were on this planet, you'd have no chance of surviving. It's incredibly close to its star, making the temperature on the planet a whopping 1,500 degrees Celsius. And believe it or not, this rock is only a level 5 on our list of terrifying planets. In this video, we're going to crisscross the universe, checking out the most terrifying places we can find, starting at a level 5, and calculating the terror all the way up to level 100. Okay, now let's check out Trace 2b, clocking in at a level 10. This one is known as a hot Jupiter. That's a name given to a Jupiter-sized gas giant that orbits really close to its star. It's 750 light years away, and it's really, really dark. Now, you might say you're not afraid of the dark, but this is a special kind of dark. This planet absorbs 99.9% of the light that strikes it. That's more than any other cosmic structure that scientists know of. On Earth, the closest thing to it is coal, which absorbs 95% of light. NASA calls this the planet of eternal night, and now that you've landed here, you see it's true. It's pitch black out there. But because Trace 2b is so close to its star, it's also very hot. And because of that, when you look at it, you can see a deep red glow. That is a view of the planet's atmosphere heating up. Spooky. Okay, on to level 15. This one is going to be uniquely horrifying. You're not only going to a new planet, but you're also going back in time, a few 100 million years. This is KOI 55.01, also known as Kepler 70b. When its star burned through all of its hydrogen, its outer layers swelled up as it became a red giant. This is the point in time where we're dropping you onto this terrifying planet. Once it was Jupiter-sized, but after being engulfed by the swelling star, it's now even smaller than Earth. If you could somehow live through this, you'd see the outer gas and liquid layers getting stripped off due to the friction with the star's outer layer. And the planet would come out on the other side burnt to a crisp. It's now at 6,800 degrees Celsius, making it one of the hottest planets ever. And whatever's left of it is slowly evaporating and will soon be gone. Okay, back to the present day. Time to visit a different kind of yuck, level 20. If you've ever wondered what it feels like to be a boiled egg, well, this is your chance to find out. I'm sure it'll be an interesting eggs experience. Get it? Eggs experience?
Oh, hey ladies!
Well, welcome to Gliese 1214b, a hot, steamy water world about 8 times the mass of Earth. But its land-to-water ratio is a bit different from our home. Of its mass, 75% is from water, and only 25% is from its rocky core. The atmosphere is also incredibly hot and steamy. The ocean, thousands of kilometers deep, and if you dive all the way down, you'll end up trapped beneath some extremely high-pressure water. And down below, it gets pretty weird as things turn to plasma. Ugh. Okay, on to level 25. Now we're going to check out a place that's not just sizzling, not just hot, but ultra super mega hot. It's Kelt 9b, a gas giant with a mass of 3 Jupiters. If you traveled by car at 100 kilometers per hour, it'd take you 7 billion years to get to. Of course, you don't have that kind of time, so pedal to the metal, we need to ramp up to light speed. Still, traveling at the fastest speed there is, it's gonna take you 667 years. And once you get there, well, it's not gonna be pleasant. This is the hottest exoplanet we've ever discovered. The surface temperature is over 4,300 degrees Celsius during the day. It's so hot that the heat tears molecules apart on the side of the planet that faces the star. If you traveled here, it wouldn't just get vaporized. The very molecules that you're made of would split into atoms. Talk about becoming one with the universe. This exoplanet is also being bombarded with a huge amount of radiation from its star, Kelt 9. So much so that it's constantly losing its atmosphere. Eventually, this exoplanet will be completely eroded. Okay, time for you to jump to level 30, what NASA calls the ultimate Frankenstein creation. 1,200 light years away, you'll find WASP-12b. It's a gas giant 1.8 times the radius of Jupiter and 1.4 times the mass. This is another one of those hot Jupiters. It orbits so close to its parent star that a trip around it takes just 1.1 Earth days. And the gravitational pull is so extreme that WASP-12b has been bent out of shape. It's shaped like an egg. But that's not its biggest problem. WASP-12b is a nightmare because it's literally being torn apart. The star it orbits is pulling material off the surface of the planet. If you were to visit WASP-12b, well, maybe you'd be pulled off too. 10 million years from now, so much material will be sucked off the planet that it'll be completely gone. Its name tells the story. WASP, a planet. WASP. Get it? No? Alright, time to visit the planet AU McB, located in the planetary system, the AU Microscopii. It orbits a red dwarf star 22 million years old. It's so dim you can't see it with the naked eye, but you can definitely feel it. Why? Well, because the star is beaming this planet with loads of radiation. Standing on this planet, you'd be hit with blasts of X-rays. They're causing the planet's hydrogen atmosphere to escape, so there's no chance of life on AU McB. Not to mention, the entire planet is trapped by a disk of dust. Good luck getting off this one. Okay, I'm ready to leave. On to level 40 and a planet called HD 80606b. I like to call this one a hot and stormy experience. This planet's orbit is no tidy circle around a central star. The orbit is super elongated and weird, and the planet moves like a comet. During its 111-day orbit, it gets extremely close to its parent star, and then it travels super far away. Okay, let's land here on the day that it's super close to its parent star. Your view from the clouds above this planet will be of its star rapidly becoming bigger and bigger. I hope you packed your cooling suit because it's going to get extremely hot. The temperature will go from 500 to 1200 degrees Celsius in just 6 hours. The heat is so intense you'll feel like you're in the middle of a massive explosion. There's no chance you'll live through this, but where could you escape to? Well, there's no relief on the other side of the planet either. This temperature causes the atmosphere to heat up, making winds blow more than 17,000 kilometers per hour. So even if you somehow survived being baked by the heat, you'd be thrown around violently by the storm. Okay, on to the exoplanet K2-141b. This one sits about 200 light years away from Earth. This is a big, rocky lava planet orbiting close to its star. So close that a year here is less than 7 hours long. The surface is incredibly hot, and oceans of magma are everywhere. But what's unique about this planet are the rocks. There are rocks on the ground, in the ocean, even in the atmosphere. In the intense heat, rocks and sodium atoms vaporize, and then they get hurled at supersonic speeds over to the cold side of the planet where they rain down as rocks. It would be like standing in a landslide. Once they rain down, these rocks fall into the magma ocean, flow back, and the cycle repeats. It's no fun getting hit on the head with rocks, so time to get out of here. From far away, this next planet looks a bit like Earth. Looks pretty inviting. But never judge a book by its cover or a planet by its color. This is exoplanet HD 189733b, and the one thing you'll be seeing in HD when you get there is the end of your life. You see, winds on this planet blow at 7 times the speed of sound. Once you arrive, you'll be scooped up by the wind, thrown up into the atmosphere, and tossed around this world in circles over and over again. And if that's not enough, you're gonna regret not taking your full metal umbrella. That's because there's glass rain falling on this planet. So if you're not destroyed by the wind, the shards of glass rain will get you. Okay, time for our next stop. Hopefully you have solid health insurance because you're on your way to the Whiplash planet. This is HR 5183b, 3 times more massive than Jupiter. This one orbits its star once every 74 years. If humans lived here, most of us would only celebrate one birthday our entire life. This planet has a weird elliptical orbit. When it's far away from its star, it moves slowly along the orbit. Then, as it gets closer to its star, it suddenly gets a lot faster. And that sudden change in speed is why it got its name, the Whiplash planet. The star's intense gravitational pull makes it speed up. This unusual trajectory also messes with other planets that might be traveling in a more orderly fashion around their stars. So sometimes HR 5183b is referred to as a wrecking ball. After that trip and a trip to the doctor to treat your whiplash, I'm sure you're ready for a new planet. Okay, we're now arriving at a level 60 of terror. WASP 107b is sometimes called the Candy Floss planet or the Marshmallow planet. Well, that doesn't sound so scary. Let's check it out. Oh, it's raining sand on this planet. Why? Well, because it's 1,000 degrees Celsius here. This temperature causes sand to turn into silicate vapor, which then rises up and reforms into tiny particles of sand too small to see. But over time, they clump up and they rain down at a high velocity, only to start the cycle over again. Oh, and also, this planet is so puffy that there's no solid surface, nothing to stand on. Ugh, it's hot, it's raining sand, nothing to stand on. Not really my ideal day at the beach. Okay, next up, the Poltergeist planet, which I'll classify as definitely creepy. It's 2,300 light years away, and it was one of the first exoplanets to be discovered. To understand why your visit to this planet is going to be super unpleasant, well, let me tell you about pulsars. They're created when a massive star explodes, losing most of its mass. But then the inner core collapses in on itself, and the whole mass turns into a super dense, rapidly spinning object. This is a pulsar. Its magnetic field is intense, and it gives out a ton of radiation. which is the kiss of death for anyone who pays a visit. Standing on the poltergeist planet, you'll feel the full force of this radiation, all types, from gamma rays to radio waves, and because of the pulsing, you'll be hit with strobe radiation, just like a strobe light. Fortunately, this is no disco. You'll also be blasted with tiny particles coming out of the pulsar. Why radioactive disco? Okay, level 70, 57 light years away from Earth, there's a planet that's particularly frightening. This is GJ504b. Don't let its inviting magenta color fool you. This whole planet is made out of gas, which glows pink. But the gas is just hydrogen and helium, so why is it pink? Well, it's because this planet is pretty young, just 160 million years old. It's still giving off heat from when it formed. The surface temperature is 230 degrees Celsius. This heat gives it a pinkish glow. And if you were to dig into the planet, you'd notice an incredibly hot core at the center. GJ504b is massive, clocking in at 4 times larger than Jupiter. Its gravity, 10 times as much as Earth's, would be deadly, making it hard for your blood to flow up. Your bones might break, and you might fall to the ground and stay there, pinned down. Okay, time to get out of this pink hellscape. Off to LTT 9779b, the shiniest exoplanet ever found. However, spending even a second here would be deadly. For one, there's the scorching heat. The day side reaches about 2,000 degrees Celsius. It also reflects 80% of the light from its host star, making it so bright it could blind you. What is it reflecting the heat? Metallic clouds. The heat causes metals on the planet to evaporate, so the atmosphere gets saturated with glass and metal vapors. Eventually, the vapors form metallic clouds. Whatever you do, don't breathe in unless you're dying to find out what breathing titanium vapor feels like. Now, if you think titanium rain is bad, well, our next stop is worse, but with a touch of class. We're jumping to level 80 and landing on L9859d, a planet 1.5 times the size of Earth. It's the smallest known exoplanet with an atmosphere. Maybe we'll finally see some life? Excited? Well, sorry, there's just one problem. This is going to be an extremely smelly experience. Don't inhale. If you do, what you'll smell is a pile of rotten eggs. Yeah, that's right. This planet's atmosphere is rich in sulfur dioxide and hydrogen sulfide, which happen to smell like a sewer. Ugh. That's probably because as the parent star's gravity stretches and squeezes it, the surface of this planet gets rocked by volcanoes. Stinky gases are thrown out with the volcanic eruptions. Now, while you're holding your breath, you won't be able to move much either. That's because the planet is covered in oceans of magma, and the temperature is hellishly hot. Okay, so much for being able to find life here. Okay, time to leave this stink hole. Let's fly to a place we call Black Hole Hell. That's a level 85 terrifier. It's called Porphyrion, and it's a spot where you'll find twin black hole jets. These jets are enormous. They span 23 million light years from one end to another. You probably want to stand way off to the side, otherwise you'll be hit with massive streams of energy and particles that come shooting out of the black hole. Energy equal to what's contained in 1 trillion suns. If you could teleport to the middle, well, you'd be instantly vaporized. Now, wait a minute, doesn't stuff usually get sucked into a black hole? Why are streams of energy shooting out? Well, that's because some of the dust and gas that gets pulled into the black hole gets superheated, and instead of falling in, it's getting blasted out. Okay, time to skip out of this black hole hell. It's time to hit level 90, which is a little bit more scenic. You'll land on 55 Cancri E, which has a sparkling interior made of diamonds and sparkling skies. Now, if you're wondering what's so scary about that, well, sorry, I forgot to mention, this world is covered with a lava ocean. More about that in a second. 55 Cancri E is only 41 light-years away. It orbits around its star 55 Cancri A in a mere 18 hours, and since it's so close to its star, it's also incredibly hot. If you landed on the surface, you'd be swimming in an ocean of molten lava. A pretty horrible way to die, but if you look up, at least you'd see some sparkling skies as you left your body. These are silicates that have evaporated to form clouds and reflect the lava below. Okay, on this next exoplanet, it's raining gemstones. Yeah, welcome to WASP 121b, where on the night side, it's raining metal and gems. This is a level 95. Shaped like a football, this hot Jupiter has a dayside temperature of 3,000 degrees Celsius. If you landed on this side, it wouldn't just be you getting burned. It's so hot that scientists say that various metals like iron, magnesium, chromium, and vanadium are superheated and now exist as gases in the atmosphere. If you look at the atmosphere, you'll see water molecules glowing as they break down into hydrogen and oxygen atoms. Now, on the night side, the temperature is half of what it is on the day side. These different temperature extremes cause a powerful wind to blow. So powerful that you get picked up on the day side and blown over to the dark side, which is also pretty hot. You'd be at 1,500 degrees Celsius. Too hot for water to condense, but hydrogen and oxygen molecules combine again to form water vapor. And if you were still alive, well, you'd have gemstones raining down on you. That they wouldn't be so much of a treasure anymore. Now, for our last stop, I'm both excited and a little terrified. You're landing on GJ1132b, 41 light-years away. It used to be a Neptune-like gas planet with a thick hydrogen atmosphere, but then it was blasted with intense radiation by its star and lost all its original atmosphere. Volcanic activity on the surface caused other gases to seep out and create a new atmosphere. But I hope you have your gas mask on, because here, at level 100, without taking precautions, you'll be breathing poison gas. There's hydrogen, methane, hydrogen cyanide, and a fourth component that's similar to the smog we have on Earth. So, yeah, breathing this stuff, your lungs are not going to be happy. Hydrogen cyanide is used in chemical warfare. Breathing in even small amounts causes headaches, dizziness, nausea, vomiting, and if you keep breathing, seizures and death. Yeah. Yeesh. The James Webb Space Telescope, launched in 2021, has been invaluable in discovering new exoplanets. It's found over 100 of them in the last 4 years, usually indirectly by observing the light that gets blocked as an orbiting planet passes in front of its star. Recently, though, the JWST discovered its first exoplanet through direct imaging, snapping an actual photo of an exoplanet. They say that this newly discovered exoplanet, named TWA-7b, is potentially habitable. But in the same breath, they also say that the temperature is 47 degrees Celsius. That's 116 degrees Fahrenheit. I don't know who's going to be habitabling it, but it sure as heck won't be me. Sounds like a job for my little buddy Chase. Hey, he's currently on his way, though, to an even hotter planet, Gliese 12b. 40 light years from us, there's a world that looks a lot like Venus. Only, unlike the most sweltering, hellish planet in the solar system, this not-so-distant planet could actually be the next Earth. This world is called Gliese 12b.
That's right, I'm venturing out of the solar system to find an exoplanet that I won't die on. And yeah, I know I've said that before, but I'm feeling much better about Gliese 12b. Way better than Kepler 22b. mean, it's like 595 light years closer to this solar system, and all stars and no weight make Chase a happy boy.
Estimated travel time 200 years.
Okay, that's longer than I expected.
Location: Pisces constellation.
Yeah, so Gliese 12b orbits this red dwarf star in the Pisces constellation, which means the planet is creative, compassionate, intuitive. Unless Pisces is placed in the 7th house, then it's bad at communication.
Chase, astrology doesn't apply to planets.
That's really naive what-if guy. I mean, Saturn literally has a ring on it. Go, girl.
Saturn is a gas giant, and it has many rings.
You know, not everybody's as into monogamy as you are, Rico, okay? And you always take his side. What's going on? Did I program you this way? Whatever, I'll get over it. Rico, now's the time for my favorite phrase. Initiate landing sequence. That really should be my catchphrase. What do y'all think?
Very little is known about Gliese 12b because exoplanets don't emit any detectable light, making it very hard for scientists to observe them. Still, scientists can deduce some basic characteristics using the Transiting Exoplanet Survey Satellite, otherwise known as TESS. This satellite stares at the sky and measures the changing brightness of a star in 20-second to 30-minute intervals as the exoplanet passes the star it orbits.
Hey, we don't need a satellite for that. I can stare at the sky with my own blinky balls.
If only it was that easy.
Oh, man, I almost had it. Now everything has a big red circle in the middle.
Well, nice try. Unfortunately, TESS can only give us data on exoplanets that pass between their star and Earth. Fortunately, Gliese 12b does just that. So this is how we know that it's roughly the same size as Earth, but is about 15 times closer to its star.
Huh. Rico, give me the stats on this red dwarf.
Loading stats.
At what point did this red dwarf make its way to Mordor? Well, Gliese might be orbiting real close to its star, but like the space gods, it's only about a quarter the size of Earth's sun. And with only 60% of the surface temperature? Yeah, Chase can live with that. You know, if this planet's sun had anywhere near the size and heat of Earth's sun, I'd be dead already. I'd be a ball of flame. And my personal preference is to not be a ball of flame.
Correct. Because of its proximity, Gliese 12b receives 1.6 times more energy from its star than Earth does from the sun.
Oh, yeah, we could put a solar panel over here. And here. And over here. Oh. You know, this could be the first fully renewable planet in the cosmos. Well, that we know of, at least. Oh, it's a bit warm here. Rico, what's the temperature reading?
62.2 degrees Celsius.
Oh, okay. Oh, man, I'd be worried about bringing you humans to this planet. I mean, you've done a great job heating up Earth already, pumping those greenhouse gases into the atmosphere. This planet is 62 degrees already, so clean energy only here, period. I'm looking at you, Kyle. Yeah. We're gonna just cover this whole section with solar panels. sofa over there.
Well, scientists haven't been able to collect any data about Gliese 12b's atmosphere. We don't know how the planet would change with any additional gas emissions.
Well, not a problem. Rico, give me an atmospheric reading. Stat.
Calculating. Atmosphere composition is 52% carbon dioxide, 44% nitrogen, 3% miscellaneous gases.
Yeah, alright. Well, that CO2 explains the heat. If Gliese 12b had no atmosphere at all, it'd be around 42 degrees. And if we had any more CO2, we'd be getting up to Venus temperatures. That would not be pleasant.
Scientists have only observed a rocky surface on Gliese 12b, but since it's in the habitable zone of a star, it could very well have water. Chase, mind doing some exploring?
Yeah, I'll look for some water. I mean, I'm thirsty anyways. And another thing that's important to know before any of you guys move here is that this planet orbits the star every 12.8 days. Do you understand the severity of what that means? Yeah, a New Year's resolution every 13 days. My resolution last year was to sign up for the What If Explorers Club on Patreon. That was an easy one. Hey, that should be your resolution too.
Gliese 12b has almost 4 times the Earth's mass. That means that even though it's the same size as Earth, its gravitational pull is much stronger.
You know, it is a lot harder to walk here now. You know, not that What If guy would think to ask. Still no signs of water. Rico, scan the surroundings for water.
Scanning.
Toot toot.
Movement detected.
What? Movement detected? You mean we're not alone out here? Oh, no. We don't know what this thing is. It could have big claws, big teeth, or worse, big feet. Oh, I hate feet. Oh. Hey there, little guy. You're okay. Your feet are an average size. Ah! Oh! Not scared. That's just got something in my throat. Okay, animal life on Gliese 12b? That means surely there must be water here somewhere. Rico, track that animal. We're gonna follow it to a water source. Where did it go? Oh, crap. You know, Rico, while you're tracking that little dude, scan for other alien life.
None detected within a 10-kilometer radius.
Oh man, I hope this little guy isn't alone out here. That'd be so sad. Imagine being trapped on an exoplanet all by yourself, the only multicellular organism. At least I have Rico, when he's not malfunctioning, which is most of the time. So I guess me and this critter have a lot in common.
Affirmative.
You know what? You don't have to be alone out here anymore, little guy. I'm naming you Charlie, and you're coming with me. Chasing Charlie, exploring the universe. Oh yeah, I like that song. Come here, little buddy. Come here. Yeah. Oh, come on, you like the sound of that. Sing it with me. Chasing Charlie, come back here. Come back here. Come here, little buddy. Come here. Ow! Charlie, you bit my finger!
Suit decompressing.
Oh no! You stupid stock website 3D animation! No! Damn this stupid planet! I was so close! You stupid red dwarf star! Suck it, Charlie.
Looks like there wasn't any oxygen in the atmosphere for Chase to breathe. But don't worry, he goes on these adventures all the time, dies, and somehow he always comes back. And little Charlie there gets to continue roaming Gliese 12b a free agent. 635 light years away from Earth, there's a world covered in liquid ocean. A world where you wouldn't die a horrible death. Probably. Welcome to Kepler 22b.
Hey y'all, I've got an exciting mission to land on and explore a planet that could be Earth 2.0. What If guy got tired of sending me to die in the solar system, so this time I'm traveling to an exoplanet where I might actually have a chance to survive. Exoplanets are like planets in our solar system, except they orbit different stars. They're cool, but there's just one problem. Exoplanets are really far away. So your solar system is this tiny little neighborhood with planets and moons orbiting around a sun in its center. And potentially, light years away, there are billions of other tiny little neighborhoods left to be explored. Now, you might have heard of the exoplanet that I'm going to. It's called Kepler 22b, and it's not that far. Okay, only 635 light years. I'll be there in no time.
Even with advanced propulsion technology, a spacecraft traveling at 20% of the speed of light would require 3,175 Earth years to reach Kepler 22b.
Buzzkill. Well, luckily, I'm at a spaceport, and they have this, warp drive technology. So I'll be there in a jiff.
The warp drive technology allows a spaceship to travel faster than light by bending space-time. The warp drive creates a bubble around the ship, moving it through space safely 99.7% of the time.
Yeah, Rico, technobabble, blah, blah, blah. Never tell me the odds, kid. Let's do this. Well, hello, Kepler.
The Kepler 22 star system is a lot simpler than our solar system. It's only got one exoplanet in it. But this exoplanet, named Kepler 22b, is intriguing. It orbits within the star's habitable zone. And that means one important thing.
Alien civilization.
Water. It means water.
Oh.
Whenever a planet is in the habitable zone of its star, it means that the temperature is warm enough for water to remain in a liquid state, instead of evaporating, like it would, say, on Venus, or freezing, like it would on Mars. And the Kepler 22 star is almost exactly like our Sun. It's a slightly smaller G-type star, which means it has a surface temperature of around 5,500 Kelvin. That's 5,200 degrees Celsius. Not too bad for a distant star system, except one thing. This exoplanet, Kepler 22b, is a lot bigger than Earth.
I don't see how that's a problem. It's just more surface to love. I mean, sure, it might have stronger gravity or, like, earthquakes. Kepler quakes? But, like, Earth has earthquakes too, and it's doing just fine.
The larger size of the exoplanet might indicate the presence of a thick atmosphere, leading to high surface pressure. This could result in water existing in a supercritical state, neither a true liquid nor gas, making it less suitable for life as we know it.
It's true, scientists think Kepler 22b might be covered with a liquid ocean, but they can't be sure what that ocean is like. Your mission is to land down there and test the water and the atmosphere.
Yeah, I was just gonna, land. So, here goes the landing sequence. Whew. It's been almost an hour, and all I see is water. Water! Everywhere water! I think I can land here. Seriously, Kepler, you are one disappointing exoplanet. Give up, Rico. Wake me up if you see any land.
My sensors read land right below us. You are cleared for landing.
Seriously? I can't even take a nap. Okay, let's land. Whoa, this atmosphere is thick! Rico, give me some stats on this planet.
Kepler 22b is a super-Earth, 2.1 times larger and 9.1 times more massive than Earth. It has an orbital period of 289.9 Earth days. It also has water.
Oh, does it? Does it have water? Oh God, thank you so much, Rico. You know, the atmosphere actually kind of looks breathable too. You know, this started out super annoying, but this is actually kind of cool.
Analyzing Kepler 22b atmosphere.
You do that. I'm gonna go see what's out there. Interesting. That feels nice. I could go skinny dipping in here.
That would violate YouTube's terms of service.
Not if it's a music video, technically. Ooh, Rico, what's the temperature out here? I'm starting to feel like some warm bread in a toaster. Toasty.
The equilibrium temperature on Kepler 22b is estimated to be 22 degrees Celsius. However, my sensors pick up a much higher surface temperature.
If Kepler 22b has a thick atmosphere, it would cover the planet like a blanket, heating it up and turning it into an exoplanetary Venus. If the temperature becomes too high, all the water will turn into vapor and Kepler 22b will stop being a habitable world. On the other hand, if Kepler has no atmosphere, well, it might become a frozen world. It would be incredibly cold at night because with no atmosphere, there would be nothing to retain the heat from the day.
That sounds just like Mercury. Not my favorite planet. My favorite planet is Uranus. Kepler 22b, it seems okay. It's a little tough to walk here.
The surface gravity on Kepler 22b is approximately 2.07 times the gravity of Earth.
Yeah, thanks. I noticed that one, Rico. Hey, have you analyzed the atmosphere yet?
Analysis in process.
Oh, so the answer was no. You're still okay.
The thick atmosphere of Kepler 22b likely contains high levels of hydrogen and helium. Those are two gases that are common on larger planets. But if there isn't any oxygen in the atmosphere, you wouldn't be able to breathe. What you should also worry about is the water. It could be acidic or contaminated with toxic elements like heavy metals. Exposure to the body could prove fatal.
Great. So, there's water on Kepler 22b, not that I can drink it, and the atmosphere's in place, and the temperature's all right. What am I missing? Where's all the life?
If life exists on Kepler, it might be microbial. You wouldn't be able to see it without special equipment.
Did you hear that?
My scans are not picking up any life forms.
I gotta check this out. I just need a break first. All this walking around that makes me sore. I gotta sit down for a second. I just need to catch my breath.
The atmosphere analysis is not complete.
It's okay. 1 second's not gonna kill me.
Analysis complete.
Something's
The atmosphere caused your lungs to collapse as a result of barotrauma.
Okay. Thank you.
It looks like the sudden increase in pressure forced the air in Chase's lungs to compress and rupture. One internal organ failure after another, and just like that, he's gone. Oof, barotrauma. That's my favorite way for Chase to die, mostly just because I like saying barotrauma. It's from a rapid change in air pressure or water pressure. You think about how your ears pop when a plane takes off. Well, now imagine that happening to Chase's entire body. It's okay, he's not real. What is very real, though, is how cool you would look in some authentic what-if space merchandise. Check out this hoodie. I'm not 100% sure, but there must be at least a few thousand exoplanets in this nebula. We got it all. Shirts, hats, mugs, the what-if book. Why not browse a while and find something tasteful that might suit you? Go to shop.underknown.com and check out a whole host of merch from What If and from some of our other hit shows as well. Okay, now back to our regularly scheduled programming. Coming up, we're going to take you to the galaxy's most dangerous planets, but first, look, I don't know how we're ranking these, but this next planet seems pretty dangerous as well. Terrifying even. Put on your titanium raincoat because I'm sending you to a planet with molten lava rain, with winds that move 6 times faster than the speed of sound. What's that? What? This blue marble-like planet looks just like Earth, but only 5 seconds on this hostile death orb would kill you. Welcome to HD 189733b. This planet is enormous, even larger than Jupiter. And to keep comparing it to the largest planet in our solar system, it's also entirely made of gas. That's why scientists classify HD 189733b as a hot Jupiter. This planet is located so close to its star that it completes its orbit in just over 2 days. Yeah, HD 189733b is 13 times closer to its sun than Mercury is to our sun. And even though its star is cooler than ours, this fake Earth is still way outside its star system's habitable zone. That means no liquid water can exist on a planet's surface. Just how this giant gaseous planet developed so close to its star is still a mystery. One theory is that HD 189733b formed right next to it during the star's earliest moments. Or it could have developed further away, only to be pulled in as the rest of the planetary system formed. But there's one thing we know for sure. A visit to HD 189733b would be a plunge into hell with no chance of escape. Now, even if you knew there wasn't a single drop of liquid water on this planet, you'd have a hard time believing it as you approached the giant blue marble. With an average daytime temperature of nearly 1100 degrees Celsius, this planet is twice as hot as Venus, and Venus is the hottest planet in our solar system. One of the reasons for this intense heat is that the planet is tidally locked to its star, just like our own moon is to Earth. That means HD 189733b takes as much time to spin on its axis as it does to revolve around the star. So one side of the planet is constantly in daylight, while the other side is shrouded in darkness. The inviting look of this world doesn't come from its oceans like it does here on Earth. No, this hellish planet gets its color from clouds of molten silicate particles. These particles scatter more blue light than red, making the planet appear blue. Silica is the primary ingredient in glass, and you should bring a heavy-duty umbrella because you'd need to take cover from what would essentially be hot, molten glass rainstorms. But that's not the only danger. You'd need to be ready to brace yourself against the extremely powerful winds that you'd find sweeping across the planet. Compared to the strongest winds on other planets in our solar system, HD's winds are almost 4 times stronger than those on Neptune. But hey, they might smell a little better than the ice giant's hydrogen sulfide clouds. Those carry a whiff of rotten eggs. HD's winds are so fast that they'd whip past you at about 6 times faster than the speed of sound. They would be extremely loud, but I think you'd be more worried about them tearing your body apart. You might be long gone by now, killed by that molten glass rain. In any case, you wouldn't last too long on HD 189733b. I really don't recommend traveling there. But there are some planets out there that can kill you even faster. Check out OGLE TR56b. This gas giant sits in a galaxy nearly 100 light years away from Earth. It's even larger than HD. Its mass is nearly 1.4 times as much as Jupiter's, and somehow it's even closer to its star, too. You'd find this world to be incredibly scorching hot. Surface temperatures on this planet average around 1700 degrees Celsius. That's so hot that it turns metal to gas, creating iron clouds in the upper atmosphere. If you got caught in the rain here, you'd find it to be an extremely unpleasant and deadly shower of hot molten iron. Your skin would burn right off, and so would your insides. But things could get even hotter. Some 670 light years away from Earth, there's a planet so hellish that it's tearing molecules apart. Meet Kelt 9b. This gas giant is almost 3 times more massive than Jupiter. It takes Kelt only 1.5 Earth days to speed through the orbit around its sun. And just like HD 189733b, it's tidally locked, with one side always facing the hot star. Landing on this planet, you'd experience temperatures as high as 4,300 degrees Celsius. It's the most scorching exoplanet we've ever discovered. Scientists call this gas giant an ultra-hot Jupiter. And those high temperatures also make Kelt 9b hotter than most stars in the universe. So hot that it would destroy you. Come on, this world rips apart molecular hydrogen gas. What do you think it would do to your body? But before you even arrive on this hot planet, you'd be exposed to deadly amounts of radiation coming from its host sun. Yeah, Kelt 9b receives about 44,000 times more energy from its star than Earth does from the sun. This radiation would cook you alive instantly. Okay, if you somehow managed to survive all the lethal radiation of Kelt's star and the unimaginable heat of the planet, well, you'd still have to take on its incredibly strong winds. Scientists think those winds could reach speeds of 60 kilometers per second. Yeah, that's 30 times faster than the winds on the deceivingly Earth-looking planet HD 189733b. Okay, so if I get this straight, Kelt 9b would swirl you, burn you, and tear your molecules apart. 1 out of 10, would not recommend. If you think meeting your demise on these kinds of hellish planets could be fun, well, I have some better travel suggestions for you. You know, not everything out there in space is utterly terrifying. There are planets that orbit their stars at a safe distance, just like the Earth orbits the Sun. We've yet to study those worlds in depth, but some of the exoplanets we've found so far could be even better for life than Earth. Thousands of light years from Earth, there could be another planet hospitable to life. Kepler 69c. And you're about to travel to this alien world to see that life with your own eyes. What would it be like to make this epic journey so far across the universe? What kind of planet would you be likely to find upon arrival? And if you did discover life, what would it look like? This is What If, and here's what would happen if there's life on Kepler 69c. Located 2,383 light-years from Earth in the Cygnus constellation is a potential super-Earth. At least that's what it's often referred to as. Kepler 69c is an exoplanet about 1.7 times larger than our planet. And it could also be around 3.5 times more massive. But there's a catch. We don't really know if this planet is located within the habitable zone of its star. If it's too close, Kepler 69c would be too hot for liquid water to exist on its surface. If it's too far from its sun, well, then it would be nothing more than a frigid world. What we do know is that Kepler 69c orbits its star about 40% closer than Earth orbits the Sun. And that could mean that it isn't actually a super Earth. It could be a super Venus. So, if you traveled all the way here, would you find life? Or a thick, scorching atmosphere boiling every drop of water on the planet? Before you begin your journey to Kepler 69c, there'd be one very important thing to keep in mind. It's far away, almost 600 times further away than Proxima Centauri, our closest neighboring star. Even if you could travel, say, 1% of the speed of light, you wouldn't get there anytime soon. At this speed, you could whip around Earth in just over 13 seconds, but to get to Kepler 69c? Well, that would take you about 238,000 years. To even make this trip possible, you'd need a super advanced hibernation pod. You know, you don't want to grow too old and die before you could even get to your destination. Am I right? Well, hibernation technology that could help you sleep for over 200,000 years doesn't exist yet, but hey, this is what if. Anything's possible. By the time your ship makes its arrival, any life that may exist on Kepler 69c today could evolve or advance into something entirely different. Think about it this way. 300,000 years ago, humans were just beginning to create stone tools and spears. And look at you now, making a trip across the galaxy. Looking back at the planet you left behind, who knows what changes would happen to our human civilization during your trip? No matter what, it's way too late to turn around now. Based on the planet's distance from its star, we know that Kepler 69c receives a similar amount of sunlight as Venus. And despite being more massive than Earth, it has a relatively low density. All this means is that instead of metals, this rocky planet is made of silicate and carbonate minerals. That could make things a little complicated. You see, with all these minerals in the crust, Kepler 69c could have a really thick atmosphere. And to make matters worse, this atmosphere would be composed mostly of carbon dioxide. Uh-oh. Did you choose the wrong super-Earth to travel to? Yeah, if Kepler 69c is anything like Venus, it would be a pretty hot planet. All because, similar to Venus, its clouds would trap the heat and create an extreme greenhouse effect. Kepler 69c's atmosphere would be caught in an endless cycle of getting thicker and hotter. But nobody said this world should be habitable for you. Oh no, once you took off your helmet, you'd instantly melt and suffocate. Like I said, life on this planet would be completely different from what you'd imagine. As you made your approach, you'd find surface temperatures as high as 475 degrees Celsius, and the atmospheric pressure would be over 90 times that of Earth at sea level. It would be like being 900 meters deep in the ocean, except you'd be on dry land. With conditions like this, you'd likely not find anything resembling an ocean here. Just like on Venus, the high temperatures would boil away all the water. Whatever life you could potentially encounter on this planet, it would need to be able to survive in these brutal conditions. Or it would have to exist somewhere else besides the surface. One place you could discover life on Kepler 69c would be up in the clouds. Around 50 kilometers up, temperatures would be much cooler. They would range from about 30 to 70 degrees Celsius. And with its low density, this planet could have a surface gravity that would be just over 70% of what's found on Earth. This weaker gravity could allow life forms to thrive in the sky, where Kepler 69c is most hospitable. Life could just be floating freely in the atmosphere. This would be another way in which this planet could have far more in common with Venus than with Earth. Probes around Venus have picked up traces of a gas that could be a potential sign of life: phosphine. If you discovered phosphine in Kepler 69c's atmosphere, it could be the result of bacteria that don't require oxygen to survive. But be ready to hold your nose. This smelly gas has an odor similar to decaying fish. On Earth, the bacteria that produce phosphine often live in swamps or wetlands, but on Venus or Kepler 69c, this bacteria could exist in the thick, oxygenless atmosphere itself. So, in the end, you may have traveled a very long way to find the smallest and stinkiest of life forms. Now, on the upside, you've just discovered extraterrestrial life. Yeah, finally, signs of life. Signs of stinky, phosphine-excreting bacterial life. Well, it's better than the alternative. Little green men with phasers and photon torpedoes, ending life as we know it. Speaking of ending life as we know it, here's the one about the universe's most dangerous planets. Not just one bad apple, but 8. 8 horrible Squid Game-like challenges for you to try and survive. Think you got what it takes? Are you feeling lucky, punk? All right, let's have at her. There are places in the universe where you could turn to ash, freeze to death, or be completely crushed by gravity. And you're about to visit them all. What conditions make some of these exoplanets so dangerous? What would happen if you set foot on them? And which planet would slash you up to bits and pieces? This is What If, and here's what would happen if you visited the galaxy's most dangerous planet. Earth exists in the precious Goldilocks zone of our solar system. That means that its orbit is within a distance from the Sun at which liquid water could exist on the surface. And with liquid water, there's the potential for life. And while the search continues for other planets in the universe that could support life, there are many that are so dangerous that you can cross them off the list right now. But before you do, why not take a death-defying journey through space to check them out? Or are you too scared? B-Sen ABB. Let's start with a planet that orbits not one, but 2 stars. And the combined mass of this binary star system is 5 to 6 times that of the Sun. If the larger of the 2 stars, B-Sen A, were placed in the center of our solar system, it would be hot enough to melt rocks here on Earth. Luckily, this exoplanet is located far enough away to keep things cool enough for us. What makes this planet so dangerous for you is that it's gaseous, just like Jupiter. There's no surface for you to exist on. And the deeper you go, the more it could crush you. At 692 kilometers down into its clouds, you'd feel atmospheric pressure that's over 1,100 times stronger than Earth's. Kepler 36b. Picture a super-Earth with a mass of nearly 4 of our home planets combined. It whips around its star in just 14 days and is too close to be in its star's habitable zone, but those things wouldn't be what makes it so dangerous for you. Kepler 36b and its neighbor, Kepler 36c, are packed together. Sometimes they're only separated by less than 5 times the distance between Earth and the Moon, meaning in the night sky you'd see this other planet towering above you. But the proximity causes some huge gravitational tides. So much so that they deform both planets. And the result? Well, if you made a stop over here, you'd probably die from the tons of epic volcanic eruptions on the surface. Ogle 2005 BLG 390LB. This exoplanet has a mass of 5.5 Earths. It takes 9 years to make one full orbit and is located far away from the habitable zone of its dim star. That means that it has a lot in common with a planet a bit closer to home, Neptune. To visit this frigid world, you'd need an especially warm spacesuit. Temperatures here would be about minus 220 degrees Celsius. That's even colder than liquid nitrogen. If you accidentally inhaled the atmosphere here, your lips would instantly suffer cold burns and your cheeks and tongue would be dealing with severe frostbite. Keep it up and you could destroy the lining of your mouth, throat, and airways to your lungs. K2-141b. Get ready to zip around a star every few hours because on this exoplanet, you'd make one full orbit in just 1/3 of an Earth day. That would be about every 7 hours. K2-141b is almost one to the Sun, and the two are tidally locked together. That means that one side of the planet always faces its star. The hot side would have temperatures as high as 3,000 degrees Celsius. And besides burning you to death, this heat creates other dangers. An ocean of magma as deep as 100 kilometers, an atmosphere of vaporized rock, and supersonic winds with speeds up to 5,000 kilometers per hour. And on the colder side, temperatures would plummet to as low as minus 200 degrees Celsius. If you landed here, you'd be exposed to rocks raining down from the sky, and they'd hit you faster than bullets from a gun. Ogle TR56b. Speaking of the weather, this next exoplanet would be one of the most insane places you could ever think of stopping by. This gas giant has a mass nearly 1.5 times that of Jupiter, and yet it's located about 40 times closer to its star than Earth is to the Sun. You'd arrive to find it has an intense surface temperature of about 1,725 degrees Celsius. This is so hot that iron evaporates into clouds in the upper atmosphere. Check the forecast before leaving your ship, or you could just get caught in a hot, molten iron rainstorm that would burn you alive. Kelt 9b. If you thought that was hot, get ready to check out one of the hottest planets ever discovered. This tidally locked gas giant receives 44,000 times more energy from its star than Earth gets from the sun. On the day side, temperatures could be as high as 4,315 degrees Celsius. That would make it hotter than most stars. At that temperature, even hydrogen molecules wouldn't be able to stay intact. You'd be a goner in less than a millisecond on this planet. PSR B1257 plus 12. Pulsars are fast-rotating neutron stars that regularly emit pulses of electromagnetic radiation. This exoplanet is a pulsar planet, so if you land here, you'd be showered in radiation ranging from visible light to X-rays and even gamma rays. Located 980 light-years away in the Virgo constellation, its pulsar star spins at an incredible 161 times per second. And it's also one of the smallest exoplanets ever found. It may be so small that there'd be almost no gravity to keep you in place. But it's the radiation that would be your demise here. Acute radiation sickness would kick in within hours, and you'd experience nausea, confusion, and possibly lose consciousness. Stick around for up to 3 days, and you'll almost certainly be in a coma. Or dead. HD 189733b. Don't let this gorgeous cobalt blue planet fool you. This world is the deadliest planet of them all. That color may look like an ocean, but what you'd be seeing are high clouds full of silicate particles. And these particles would tear your body apart. The winds here are blowing at speeds of up to 8,700 kilometers per hour. That's 7 times faster than the speed of sound. And if the wind itself couldn't kill you, the glass rain certainly would. All that silicate would hit you at thousands of kilometers an hour. It would pierce your body over and over, which is why this is nicknamed the Slasher Planet. Okay, so maybe these dangerous places wouldn't make for the most fun vacation. So why not explore a little more locally first? Like a day on every planet in our own solar system. "635 light years from where you are sitting, way out there in outer space, lies a planet. The first planet to be discovered within the habitable zone of a sun-like star. Its name is Kepler 22b. When a planet is located within a star's habitable zone, it means there's a chance that liquid water exists on its surface. And where there's water, there's also the possibility of life. Human life. How long would it take to get to Kepler 22b? What would the weather be like over there? And why would you need to get jacked before arriving on this new planet? This is What If, and here's what would happen if you lived on Kepler 22b. Kepler 22b is what scientists call an exoplanet. It's a planet outside our solar system. Spotting an exoplanet like Kepler 22b is often not easy. The bright glare of the stars they orbit tends to keep them hidden from our telescopes. What did scientists come up with to get around it? Looking at the stars themselves to see if they can find anything unusual about them. They spotted Kepler 22b using what's called the transit method. They watched Kepler 22, the star this exoplanet orbits around, and noticed that its brightness changes over time. That was because Kepler 22b was blocking the star's light. With this, scientists were able to learn both the size of 22b and how it orbits. And it looks like this distant space rock could become our next home. Okay, but what do we really know about Kepler 22b? Its mass is 36 times that of Earth, with a radius of 2.5 times larger than ours. 1 year on Kepler 22b is 290 days. It's also located 15% closer to its star than we are to the Sun. If Earth scooched over that close to our star, you'd be fried. Kepler 22b, on the other hand, is lucky to have a sun that is remarkably similar to ours, but also smaller and cooler. This close proximity to its star allows the planet to receive about the same amount of sunlight as we get over here. The temperature on Kepler 22b could be about 15 to 22 degrees Celsius, similar to Earth's spring weather and quite habitable if you ask me. But our galaxy can be a cruel place, and not everything is good news. Some models suggest Kepler 22b is rotating on its side, kind of like our very own Uranus. This may sound insignificant, but it adds potentially deadly complications. This would mean that its north and south poles are shrouded in either darkness or sunlight for half a year. And this ain't simply a matter of whether you're a daytime or a nighttime person. A world like Kepler 22b spinning on its side means that temperatures could change from boiling to freezing, which wouldn't be great for human life. I know, what a bummer, but don't despair yet, because our galaxy is also big enough to include some hope. New studies suggest that Kepler 22b might be covered in an ocean 50 meters deep, and that ocean would be able to act as natural climate control, keeping the wild temperatures at bay. You see, an ocean can store heat in the summer and release it during the winter, which results in a mild climate. Like you needed another reason to live close to the water. But hold on. How would you even make it all the way to Kepler 22b? I mean, even if you were traveling at the speed of light, it would take you 635 years. Your best bet could be to hibernate through the trip inside a device that preserves your body way past its natural lifespan, like cryogenic sleep. NASA has already developed a cryosleep chamber that can lower an astronaut's body temperature to as low as 32 degrees Celsius. This would trigger natural hibernation, during which catheters would provide your body with nutrients and remove any waste. But even in cryosleep, it would be quite the long, risky trip. This leads us to the most dangerous part about this journey. All that remains unknown about Kepler 22b. For starters, we still don't really know what gravity is like there. It could be twice as strong as our planet's. If that was the case, a 10-kilogram sack of potatoes would now weigh 20 kilograms. And your body would also factor into the mix. Is your current weight 75 kilograms? Well, good luck suddenly dealing with 150 kilograms of you. And just for safety, settlers such as yourself would need to bulk up. Really bulk up. Only through intense strength training would you increase your chances of being able to walk on Kepler 22b. And once you got jacked on Earth, you'd have to figure out ways to preserve that muscle through all 635 years of lightspeed travel. But humans aren't the only life form that would be affected by a stronger gravity. Plants brought from Earth for oxygen and nutrition might not survive on Kepler 22b when you try growing them there. And if you brought any animals with you, they'd need to step up the evolution process. Higher gravity could lead to creatures developing additional legs to move around. It could also determine the location and size of internal organs. But the mysteries don't end there. Scientists still don't know for sure that Kepler 22b is even a rocky planet. It might be gaseous, similar to Neptune, or it could be your first settlers woke up from your cryosleep and found yourself on a gas planet. Yeah, that would be a downer. You wouldn't have a solid surface to even land your ship, not to mention a place to set up camp. In that case, you and your crew would need to figure out how to build a cloud city orbiting the planet. If you landed on an ocean planet, a submarine town would be in order. Discovering Kepler 22b is a rocky planet would be hitting the jackpot then, right? Well, not so fast. Venus is also made of rock, and yet its dense atmosphere, consisting of greenhouse gases, makes it uninhabitable, with scorching temperatures far too hot for liquid water. If this was also the situation with Kepler 22b, our only chance at thriving on this exoplanet would be to employ robots that could build underground shelters. The place where maybe, just maybe, the temperature might be cool enough for you to bear. It just goes to show you that a prime location is no guarantee for human survival. And as exciting as it might seem to find other worlds to inhabit, our own Earth remains the perfect habitat for humanity. But sometimes, the slightest change can shake its ideal balance. Just turn off the oxygen supply for 5 seconds and a raging sunburn is in the cards for you. Oh my. And thus marks the end of today's pain and suffering. Well, you did it. You survived. I didn't think you'd make it through the magma oceans and the supersonic winds, the 7,000 degree temperatures, the glass rain, and the radiation poisoning, but you did. Nice work. Anyway, thanks for joining me on this extraordinary, erratic, and eccentric epic through the universe's fine establishment of exoplanets. It was a pleasure doing business with you. And maybe next time we'll go searching some of these planets for intelligent life. Hopefully just a little less intelligent than us. But that's a story for another What If. Hey everyone, thanks for joining me today for a fun-filled, fast-action, and fact-packed trip through the cosmos to learn more about the exoplanets we know about, and everything we don't know about the exoplanets we know about. We'll travel to the universe's most dangerous planets, our most terrifying planet, and a few planets we might be able to call home. But be warned, this is